Hi, in this video I want to solve a kinematics problem with you, so let's get started with this problem here. A skateboarding turtle cruises at a velocity of 12.0 meters per second when he arrives at the base of a hill. As the turtle climbs the hill, he loses velocity at a uniform rate of 1.2 meters per second per second. I've started to draw a picture here. I want to just label my picture that he's starting out, this turtle starts out at 12 meters per second before hitting the base of the hill, and then it's going to start slowing down after that. Let's answer this first question first. It says, how fast is the turtle moving after 3.0 seconds? We're going to use the guess method here, which is my way of kind of thinking through a problem. It doesn't solve all our problems, but it helps us get a starting point. And so for the G step, we're going to write down all of our given information. So we know that the initial velocity of the turtle before he starts slowing down is 12.0 meters per second. And I know that just from the context of the problem, like thinking about it, picturing it, that's what velocity he starts at. And then I also know there's an acceleration. He's losing velocity. How much velocity is he losing? Well, it's 1.2 meters per second squared, or meters per second per second. And then we also know that the question's asking, okay, after 3 seconds, how fast will he be going? So 3.0 seconds is the time of travel for this turtle. Our unknown for this particular question is we want to know what is the final velocity of the turtle. Okay, so using all of this, or seeing all this information and what we want to know, we look at our kinematics equations and we want to see, okay, which one is going to best suit our needs here. We have a lot to choose from. So I think the best one, we're looking for final velocity. So, if I see one that has final velocity in it, I'm immediately drawn to that. But this one right here, final velocity, has a displacement. We don't know how far the turtle has traveled, so we can't use that one, at least not right away. I see this one down here. This looks like the best equation because we do have an initial velocity and an acceleration and a time. So let's use that equation. That's kind of the way you think through this part of the process. You pick an equation that pieces everything together for you. So the final velocity of the turtle is the initial velocity of the turtle plus the acceleration times the time. Now we're ready to substitute our quantities that we know into this equation. So the initial speed was 12.0 meters per second plus negative 1.2 meters per second squared times 3 seconds. All right, and so that's going to give me, for my solve step here, completing the guess method, we have 12.0 meters per second minus 3.6 meters per second. And so our final velocity of the turtle is going to be 8.4 meters per second. So that tells us how fast the turtle is traveling after it starts slowing down, going up the hill. It's still moving forward, still got some positive speed there, but it will continue to slow down as it goes up the hill. Question 2 says, how far does the turtle go in 3.0 seconds? So we still have the same given information before, and we're even using the same amount of time. So I'm not going to rewrite all of the givens again. I'm just going to do a new unknown over here. So our new unknown is, how far does the turtle travel? So now we want to choose a new equation. This time it does have the displacement in it. So we're looking for one that has delta x in it. That's going to be one of these last two equations here. And I think, we could probably use either one of these equations because we just found the final velocity. We just calculated that. So we could use this equation, but this one's a lot easier because it's already arranged for delta x. It's already solved for delta x, the displacement. So let's just go with this equation here. So that's going to be delta x equals initial velocity times the time plus 1/2 acceleration times squared. So now we can substitute in our numbers. We have 12 meters per second multiplied by 3 seconds plus 1/2 times negative 1.2 meters per second squared times 3.0 seconds squared. And then now we're going to solve. So I'll do this in a couple of steps here. So this is going to be 36 meters. The seconds cancel out. And then this is going to be a negative number here because of this negative sign. I do 3 squared, that's going to be 9 seconds squared, times negative 1.2 times 1/2. All of that together is going to give us 5.4 meters. The second squared gets canceled by this seconds squared, so we're just left with meters. And so the displacement of the turtle going up the hill is 31 meters. And I'm rounding this. It would be, if you just did this in a calculator, it would be 30.6 meters, but this doesn't have a decimal place in it, so we're gonna cut that decimal point off, and we're just gonna round it up to 31 meters for the displacement of the turtle, how far it goes in this time. So that's all I've got for you in this video. Remember, everything you have is a gift.